Assalamualaikum and good morning to everyone. Okay, so today, we would like to present the topic on the chapter 2 of operating systems, which is operating system in the user view, whereby we will look at the operating system in the user perspective. So at the end of this chapter, you will learn to be able to identify the types of operating system user interface. Okay, and I explain about how the file systems. Okay, how I explain about the device management. Will describe about the device driver interface, describe device driver API, and also describe about device driver kernel interface. And here is a presentation outline. Okay, you have a three part. 2.1 is about the type of user interface. 2.2 will be talk about the file system, and the 2.3 will talk about the device driver. But in this video, you will cover only the 2.1, which is the type of user interface. Alright. Okay, the type of user interface. As we know, okay, one of the component of the system is provide the user interface. So the user interface is basically a program or a set of programs that sits as a layer above of the operating system itself. So the program processes user the commands, okay, in order to create the computational structure and access the resources. Sometimes this user interface is also known as a shell, or it can be as a terminal. So the user interface will provide the mechanism for the system operator and the user to communicate, which allow the user to communicate with the operating system and request operating system services. So they have three ways, okay, how the user interface can be implemented. The first one is a command interface. So command interface basically, you use a command interface by accepting the command directly from the user interface. Example, command line interface and or a graphic user interface. The second way is a command language. This command language basically will accept and execute the groups of commands as a program or as a batch, okay, which is also known as a scripting language. Okay, for example, you want to do some backup, okay, automatically backup, we run some backup script, okay, by providing or using a command through the scripting in order to do a backup, automatically backup. Okay, the third one is application programming language, okay, or to accept and perform the request directly from the user program. Okay, so the user interface basically is near to the user system program. Okay, so the user interface is either using a graphic user interface, okay, command interface, okay, use a batch, or using a command line. So this user interface, okay, will provide the interface for you in order for you to request, okay, whatever commands that you want to use, okay, will go into the system call, and this is the provide the interface in order to provide the services to the user. For example, is you got the user mouse, okay, in order to click to open your file. So this request of opening the file, okay, will go to the system call, and this system call will send to the file, okay, so the file system, okay, and then this will be then they will be respond back to the user by you can see that your file is being opened. Now we look into a 2.1, which is a user interface. Okay, so user interface, okay, you will learn about the command line interface. So command line interface is one of the example in the user interface, which is use a mechanism by interacting a computer system by typing a command. You use a command, okay, in order to perform the specific task. Okay, this method is by instructing the computer in order to perform a given task by entering a command. Okay, the system will wait for the user in order to conclude the submitting of the text command by pressing the enter key. Okay, for example, when you type the DOS command ataupun the command prompt, we can see that the cursor will blinking, okay, to waiting for the command from the user, okay, until you pressing the enter key. So the command line interpreter, okay, then the command line interpreter will receive, will analyze and execute the requested command, and then appear the outputs, okay, as required, as a command required. Okay, for example, in the Unix itself, okay, they use a user interface is known as a shell, and normally kita akan nampak command line interface ni banyak digunakan di dalam Unix dan juga MS-DOS. Okay, so they have two ways, okay, a command line interface can be implemented either using a command interpreter itself and most common through the system program. Okay, alright, so contohnya kalau command interpreter kita ada add, delete command, kita ada edit, kita ada new rows and so on. Tapi kalau most common through the system program, okay, kita akan menggunakan a specific command in order for you to interpret the command. Contohnya rm is actually remove the file. So this remove rm command ni actually do not understand by the command interpreter. You need to search the file of rm and load the memory and execute it to the file. So it allows programmer to add or create their own command to the system. Okay, the command line is naturally user interface that is navigated through the typing command prompt. For example, kalau kita pakai MS-DOS, okay, kita akan nampak generally bila kita buka the DOS command prompt kita akan nampak a C prompt here. But in the dalam Linux pula kita akan nampak sama ada it can be a percentage ataupun in the dollar sign. Okay, unlike a graphic user interface, the command line only use a keyboard. Okay, normally kalau graphic user interface, kita akan menggunakan keyboard, mouse in order to navigate by entering command, which is not utilized so much. Okay, for example here. Okay, we can see that this is example of command line in a MS-DOS, which is already used in your lab. Okay, this is a dollar sign. Okay. Alright, in the Ubuntu Linux, okay, it's also hashtag. Okay. So what are the differences between the command line interface? Okay, what are advantages and disadvantages of the command line interface? Okay, the command line interface is more fastest for the experienced users. Okay, however, this command line interface is difficult to learn or to use because it's required to memorize the command and we have to memorize also the format of the command. Okay, so even though this command line interface require a less memory, okay, but it may happen errors, okay, in order for you to retype the command. Okay, and be able to use a wildcard in order to apply a command to multiple file or multiple directories. Okay, and this command line interface normally is not attractive as a compared of the graphic user interface. Okay, now we go to the next example of the user interface, which is a graphic user interface. So in this graphic user interface, as we know, graphic user interface is more towards user-friendly method, okay, for interfacing with the operating system. Okay, so the graphic user interface is sometimes we call an object-oriented interface, or we call known as an icon-based interface. So it allows user to move, okay, the mouse to the positions is pointer on the image, icon, screen, okay, the file, the directories, and all the system function. Okay, the graphic user interface can use in the computer, in the devices, in the MP3, the portable device, gaming device, and many more. So it can represent information and the actions through the graphical icons and the visual indicators, okay, as opposed to the text-based interface type command. So ini adalah normally that's people will use, okay, will look into it, okay, we look on the operating system. Okay, dia akan tengok graphic user interface, how interactive the responsive, how fast the response for each of the icon or the graphic user interface that we use in the operating system. In the graphic user interface, okay, for example, in the Windows operating system, is offer two unique tools. Okay, let's say taskbar, start button. Okay, each operating systems have the way of the design, have the unique design. Okay, alright. For example, like Windows, we have a taskbar and the start button at the bottom, at the left top, at the bottom, at the left bottom. Okay, and then it's used to run and manage the program. In the graphic user interface, the user can run a multiple program and in each separating windows. Okay, the menus will let user to avoid the memorizing and typing of command names. Okay, so we have a list of menus. Okay, and then we select the menus rather than we typing the command. So the dialog box is a special windows which is appear, okay, when the program or the operating system needs more information before the completing a task. Okay, this example of graphic user interface of Windows 98. And this is the graphic user interface that used in the Mac OS. And this is the graphic user interface that been used in the Ubuntu. So there are advantages and disadvantages of using a graphic user interface. Or even though the graphic user interface is easy to learn and use, but it is harder to implement. Okay, because when you want to implement the user interface or icon base, it must be designed, okay, by using a human computer interaction guidelines. Okay, so it's less training required because normally the graphic user interface is use the icon which is meaningful, okay, and towards the user, which can be understand by the user. Okay, and however, this graphic user interface require hardware and software, and require a lot of money in order for you to implement, okay, the graphic user interface. And the software is more complex. Okay, the heavy of the graphic user interface, the more complex of the software, and it's difficult to write. Okay, so this is the differences between the command line and the graphic user interface. So when you differentiate the command line interface, okay, and the graphic user interface, you have to provide the criteria, okay, for each of comparison that you for each component that you differentiate. For example, in ease of use, okay, the command line, memorizing information needed. Graphic, although the new user may have a difficult at the time learning to use the mouse to operate and use a graphic user interface. In terms of the control, okay, command line are much more controls, okay, compared to the graphic user. Alright, and this is another differences between the command line interface and the graphic user interface in terms of the multitasking, in terms of speed, in terms of the low resources, in terms of the scriptings. Okay, and so what is your choice? Okay, so it depends on you. Okay, whether you want to use a command line interface or whether you want to use a graphic user interface. Okay, it depends on you. Okay, how familiar are you to using the command line interface or the graphic user interface. Okay, now we are going to present, okay, 2.2 of the operating system in user perspective, which is another component of the operating system which is quite important, okay, for the operating system, which is a file system. So as you know, the file system for each operating systems are different. Okay, therefore that's why when you are install your programs, okay, your programs, they require what kind of operating system, because in this chapter, in this topic, we will learn, okay, the file system architecture and the structure in Windows and also a Linux. we going to the file system in terms of the concept, process method, file mounting, directory structures, file sharing, and also the file protection. So in the concept of our system, file system is mostly a visible aspect of the operating system. It's actually the abstractions, how the systems will be stored, to retrieve and update a set of files. So file can be a collections of information that's been recorded in the secondary storage. So this is your files are in the storage devices, which is non-volatile. So the content of the file is persistently remain permanently stored even the power failure or the system will be rebooted. So it can be either a program or the file can be either a program or it can be a data. So when they use terms of files that have the types of data, it can be in either in numeric numbers, alphabetic, alphanumerics, or in the binary. If the file can be a program, it can be such like a source program, executable programs, the text, the file records, and so on. So now we look into the how the files will be stored right, how your data will be stored into a file. So the file can be either in the fixed length, alright, either in a variable length, so it depends on the devices, or the storage, the types of the storage that you store your data. For example, if you save your data in the tape backups, for example, so they have used a D format variable length, which have 8 bytes, alright, and the 16 bytes and the 24 bytes, so for the disk, we use a V format variable length, whereby in this byte have a 2 byte count field, where in the data is stored, the variable length record format will record the format, the site expand to the fit the content, and indeed it takes times more times to access. We'll look into the memory hierarchy itself. Kita akan tengok dari segi size, lebih besar size storage itu, dan lebih banyak masa yang dia ambil untuk dia access to you punya file. Now kita tengok dari segi file structure of your file system. So ada yang file structure yang simple record, simple record structure. So simple record structure normally they have a lines of file, the fixed length ataupun variable length. Kalau the complex structure, dia adalah formatted documents or it can be a reloadable file. Reloadable file. So it can simulate the last two with the first method by inserting the appropriate contour characters. So who will decide the file structure is the operating system and also your program. So therefore, whatever your program you install, so they will follow your punya operating system. If your programs is running if your computer is running on the Windows platform or in the Windows operating system, so you have to install or download the programs in the Windows platform. If your laptops or PCs are using a Mac, so you have to download the file or the programs that are running to the Mac, because every types of operating system have their own file structure. So the file structures can be in the 4 categories, which is a text file, source file, object file, and also executable file. So for example, in the text file can be a sequence character organized into a file, and the source file, it can be a sequence of the subroutines and the functions, and the object file is normally a sequence of bytes that organized into a block, and the executable file normally a series of code sections which are loading into a memory and also in the file system, normally they are running in the layered form. Okay, so if we start with the application program. Okay, so your application programs will create the logical file system, whereby in the logical file system you have a manage metadata. Okay, the manage about your data, about data. Okay, they maintain the file structures, okay, through the file control blocks, and it are responsible into the some protection and security. Okay, the next, okay, when your file has been created in the logical form, it will be organized into a module. Okay, so this module will know about your files, about the where is your block of file will be located logically, and also the physically, okay, where your file is being physical blocks, okay, will be located. So it include the free space of management. Okay, free space of management and will free space management, and also we will identify the unallocated blocks, okay, in this file organization module. Then in the basic file systems, okay, normally we have a generate a command to the device driver. Okay, we write the physical block on the disk, okay, whether we want to save the whether we want to save the file, ataupun we want to write the file into a disk, or whether we want to read, okay, from the disk. Okay, and then in the basic file systems, okay, we have the input output control. So normally input controller consists of your device driver and also the interrupt handler. Then we'll go directly to your devices. Okay, so each of your files have their own attributes. So these file attributes will contain the name, the types of file, the locations of your files, okay, the size, the protections, okay, the time, date, and the user identifications, and also the informations for file are being kept in the directory structure, which is maintained on the disk. So this is actually a Unix file, example of the file attributes in the Unix, whereby you can see that you have a you have a types of file, whether it's a directory or file, and here is with the permissions of the file, and this is the link, and this is the owner of the file, and this is the group of the file, the size, and also a date, and at the end of this will be your file name. Okay, this is example of the Unix file attributes. Okay, now we look into the file operations. In the file operations, okay, we can have a create the file, writing the file, read the file, repositioning the file, you rename the file, you delete, and you truncate it. So this is the file types or the name extension. Is normally you are familiar with this. Okay, okay, you can see when you open your files, okay, whether in the C drive or D drive, you can see each of your files, okay, have this file extension. For example, when you are running your code, your program code, okay, so whether you run on the Java or whether you run in C++, okay, so you can see that your file name, your file code, okay, your file source code, okay, will be under Java. Okay, or ASM normally is for assembly language. Okay, another example is library, for example. Okay, so library file normally they have a .lit file. Okay, normally file extension is, will be at the end of your file name. Okay, so MPEG files, okay, for archiving files we have the .arc, we have a .zip, we have a .tar, and for multimedia file types, okay, we have the .mpeg, .nov, .mp4, and so on. Alright, so now we look into, okay, how the files, okay, can be accessed. Okay, So they have access method. So the file system has a method in order to storing and organizing the computer files and the data, the content, to make them easy to find and access them. So any access method will describe the manner and the mechanism by which a process accesses the data in a file. So this access method provides the standard interface between the application and also the file system and also devices that hold the data. So the different access method will reflect the different file structure and the different ways of accessing and processing the data. So most flexible is allowed of index sequential files and the least with sequential. Access method. They have two common access method in the file system, either in the sequential access or it can be a direct access. Basically, they have three. One is a sequential access, one is a direct access, and another one is a random access. But normally, in the file system, in this topic, in the syllabus, okay, normally we cover only two methods, which is a sequential access and also a direct access. Okay, in the sequential access is a simple access method, okay, whereby the file will be read and write sequentially, okay, starting at the beginning of the file and moving to the end. So normally operating system use this address for the last byte read to access the next sequential record. So therefore, the current byte address must be updated every time when the record is being accessed. So example of the example of file that use the sequential access method are the program source file and also a binary files. Example, you punya program source code file. So bila kita run the source code file, dia akan read from one at the beginning of your file, the line of code, until to the end. Okay, that is sequential access. Okay, so normally the sequential access ni, sequential access normally have a read functions, the write next function is set, no read after last write. Okay, and we have a rewrite function. Okay, so in the second method, okay, of our file being accessed is a direct access. So direct access is also known as a relative access. Okay, whereby in the direct access allows random access to any file block. Okay, you can allows, okay, for your file to be accessed in any blocks randomly. So this method is basically on the disk model of the file. Okay, so direct access is more familiar or obviously being used in your disk. So it allows program to read and write the record rapidly with no particular order. And this method normally involves the constructions of an index of the file. So it's normally greatly used, okay, for the immediate access to for the large amounts of information. And normally, okay, it can be used in the database and by providing the query on the particular subjects. Okay. So this is direct access. You have a read, write, and positions, and the number of related blocks. Okay. So directory is basically all the modern operating systems has adopted in the hierarchical directory model in order to present the collections of the file. So the directory contains the information about the files, including the attributes, the locations, the ownership, which is actually managed by the operating system. So the directory itself is a file accessible by the various file management routine. Some information in directories is available to users and application and is generally provided indirect by the system routine. So objective of directory can be implementing of this is to be efficiency, okay, by providing the locations of the file more efficiently. Okay, naming must be convenient to the users. Okay, we normally people or the users convenience of using the name of the file which is convenient for them to use. Okay, Grouping essentially you can provide a logical group of files, okay, by using based on the properties, for example the Java, the program, the all games, okay, and so on. Okay, directory structure can be collections of nodes that containing information all about a file. Okay, so the directories and also the file. Both directory structure and the file will reside on your disk. So the backup of a disk to structure can be kept on the tapes. Okay, so this is normally how your system file has been organized. Okay, so in these sections, okay, you can see that okay you have two partition A and B. Okay, and you have a part A directories and the file, part B partition B directories with the file, okay, and their this, okay, and the and on your right side, okay, you can see that you have a two disks, this 2 and this 3, but you only have one particular directory. So which one are more organized, either in your left side or in the right side? Yes, okay, it should be in the on your left side, okay, because okay you partitions, okay, your files and your directories into a different partition, even though you have used one disk, because if anything happens to that particular directory, it won't affect to another directories, okay, compared to the right one. Okay, when you see the right one, even though you have a several of disks or storage, but you only have only one directories, if anything happens to this directory, it will be affect the whole of directories and the files in the same directories. For example, you have a viruses that infected on your C, so all the C will be infected, okay, have a potential infected to that particular viruses. So before this, you learn on the file operations. Okay, so this is the basic okay operations of that. They almost the same of the file. Okay, but the differences between the directory and the file are the functions traverse. Okay, in the directory, we can operation in the directory, it can have a traverse. Traverse is normally used for the backup, because when you backup your files, okay, using a backup systems, okay, they ask for the which particular directory or which particular directory that need to be backup. And when you restore back, when you restore your files, okay, when you restore the directory, they will ask the specific or the particular directories. That's why the traverse operations is being used in the directory, not in the file. Okay, so directory structure, you have a 3 level. In the basic directory structure, you have learned in 3 level. First, in the single level, okay, another one is a 2 level, and we have a 3 structured directory. Okay, in single level directories, okay, this is a very simple directory structure where all the files has the same directories and easy to support and will be understand. Okay, so single, okay, we have a directory, one single directory, and you are being store your file in the same directories. Okay, so all file in the same directories. Okay, easy to support and easy to understand. But the problem is when you have more users, or you have more users, and when each of the users have numbers of files which is being increases. Okay, all right, so when you have numbers of users, more users, okay, more files, okay, right, so the file can be duplicated. So in the single level directory, you cannot have the same name file. Okay, So in the two-level directories, okay, all right. So when in the two-level directories, okay, each of the user has his own user file, okay, which is being this type of directory structure are more towards to solve the problems on the single level directories, okay. So each of your user have their own file, and each of will list only files of the single users. So in the two-level directory, you are using UFD, call it user file directories. So in each user file directory have a similar structure. Maknanya, for example, kalau you ada create different users, so for example, one is for you as an admin, another one is for your parents, okay, for um, your siblings, okay. So each of these users have same similar structure with the other users. So different users may have a file with the same name, as long as the file within each of UFD are unique. So the operating system cannot accidentally delete the another user file that has the same name, because the operating system confine the search to the local UFD, user file directory. Okay, this is an example of two-level directory structure. Okay, in this two-level directory structure, okay, you have a user. Okay, so you have user 1, user 2, user 3, user 4. Imagine you have a user account, okay, admin, parents, okay, your siblings, your sister, your brothers, okay. So each particular users have their own directories, okay. Even though you have uh, the same file names, okay, it will be have a file name, the same file name, it's okay, because in these two-level directories, they will identify as each user as a unique. Okay, so each of user ni unique. Okay, so user ni unique. Contohnya dekat user 1 you have a A directory, user 2 ada A, user 3 ada A, user 4 pun ada A. Okay, walaupun A ni directory yang sama, okay, tapi masih boleh digunakan, kerana in the operating systems, okay, they treat each of particular user as a unique. Okay, so user file directory. So therefore, you can see that in the two-level directories, okay, you can have the same file name and the directories in the different users. Okay, now look into the advantage and disadvantage of two-level directories. Okay, in the two-level directories, you provide the path name. However, in the disadvantage, each user directory have a simple list of files and the particular users. Okay, and the problem with the two-level directories is cannot provide a grouping capabilities. So therefore, it will be solved, okay, by using tree structured directories. Okay, in the tree structured directories, it allows users to create their own subdirectories and organizing the file. So the subdirectories contain a set of file or subdirectories. Okay, so example of tree structured directories that is commonly used adalah MS-DOS. Okay, MS-DOS is tree structured directories whereby they have a tree has a root. Every file system has unique path name. So when you have a tree structure like this, okay, they have a root. Okay, root or we known as a parents. Okay, so root or we known as a parents, and each from the root to the root or the parents to the child will be unique, will be treated as a unique part. Okay, all right. So all the directories can have a file. Okay, all the directories and the files have names. Okay, and it will be separated, okay, by using have using a separator in order to indicate whether you have a subdirectory or the file will be located in the directory. For example, in the Unix, they use a slash, and in the DOS, we use a backslash. Okay. So this is a directory structure. Okay, tree structure directories. Normally, we have a root. Okay, so the parent should be a root. Okay, and then followed by the directory. Okay, so in the tree structure directories, able for grouping. Okay, they're able for you to do some grouping capabilities. Okay, they're able to groups your files. Okay, and each of these will be treated as a unit. So this is what we call a tree structured directory. So every times we do from the root. Okay, for example, spell. Okay, so and they create the subdirectories. Okay, for each of the subdirectories will be treated as a unit. So therefore, there's no problems. Okay, for the file or directories that have the same names. Okay. Right, so in the tree structure directories, okay, the path name we call the absolute path. Okay, absolute path must be begin with the root and followed by the path down to the specific file. And also relative path, okay, basically they define the path from the current directories. Okay, so how we want to know to identify whether they as an absolute path or a relative path? Okay, absolute path must start with your root file. Okay, it must be start with your root file. Okay, in the Linux, root files will be represented by slash sometimes. Okay, it can be not as a root. Okay, sometimes it's a root, sometimes it's a b slash. Okay, so relative path name is basically a part of the current directory. Okay, so for example, you have a root spell mail PRT first, and when you have a relative path, okay, for example, you are in root spell mail. Okay, you are already inside the directory of root spell mail. So the another subdirectories for PRT and first will be as PRT and first ni as a you punya relative path. Okay. Alright. So the tree structure directories for creating a new file will be done in the current directory. For example, when you want to remove your file, so you type the command line of rm followed by the file name. Okay, and mkdir, which has been learned in the lab. Okay. So part and directory, okay. So in this topic, the Unix file system is laid out as a hierarchical tree structure. This anchor a special top level directory known as a root. Okay, so Unix memang dia punya top level dia is known as a root. Okay, because in the tree structure directory can have a many childs. You can have many but only one parent directory. Okay, so you can have a many child as you like, but you can only have one parent directory. Okay, even though the tree structure directories has solved the problems with the duplications and also grouping capabilities, but in the tree structure directory, okay, they are unable to do some sharing. Okay, so therefore, in the Acyclic-Graph Directories, to solve the problems, okay, solve the problem of tree structure directories, okay, by providing the shared subdirectories and also a file. You have a same file or directory can be in two different directories, and you can share the file and the subdirectory can be implemented by providing the link. So a cyclic-graph directory structure is more flexible and a simple tree structure, but sometimes it is more can be complex. Alright, so in the cyclic-graph directories, what the main difference is, okay, they're still the same as the tree structure directories. However, they're able to share the subdirectories. Okay, they share this the file ataupun they share the subdirectories. Okay, for example here, the count of the directory dig and 12, okay, share the same file. Okay, and then for example, the directory of W in the dig directory here share the same subdirectories of list. Okay, so if this file has been shared for the subdirectories, so both different directories can able to access the same file because they already shared the directory. Okay. So a cyclic directory, even though you have allow for sharing, okay, so we have another types of directory we call a general graph directories. Okay, general graph really allow for the sharing of subdirectories and also files, but in the general graph directory, okay, they have guarantees. Okay, they allow only a link to files, not the subdirectories. Okay, so is in order to this general graph directory normally to avoid, okay, the cyclic, okay, a cyclic ataupun loops happens, okay, in the directories. Okay, for example, uh, we have a garbage collections. Okay, garbage collection is to determine when the last reference has been deleted and the disk space are reallocated. Okay, for example, in the database. Okay, in the database, okay, you have a multiple users. Okay, access the same database. Okay, one of the users, okay, is modifying the data, and another users want to access the file at the same time. So what happens is the user who access the file, okay, will have a garbage collections of data. Okay, because they're not reading the updated files or the data, the updates, okay, data. So it travels the entire file and mark that can be accessed, and it can collect everything which is not marked onto the free space. Okay, only used when the possible cycle in the graph. Okay, so the general graph ni normally kita akan pakai, okay, when they have a possible cycle in the graph. Okay, okay. So macam mana dia nak detect ada cyclic or not? Dia akan ada satu we call a cycle detection algorithm in order to determine, okay, whether this directory actually have a cyclic or not. Okay, so another you have to know about the file system is about the file system mounting. So each file system must be mounted before it can be available to be processed or on the system. So the multiple file system trees can be mounted together. Okay, the procedure mounting file system is followed. Okay, for example, the operating system given the name of the devices and the location within the file structure is the way to attach the file system. We call a mount point. So operating system verify the devices that contain a valid file system by asking the device driver to read your device directory and verify that the directory has an expected format. So the operating system notes, okay, will notice, okay, the directory structure of the file system that be mounted at a specific mount point. Okay, file system mounting is very normally implementing inside the Linux. Okay, obviously nampak sangat file system mounting banyak digunakan di dalam Linux. Okay, even though in the Windows file system mounting is also required, but it will be done automatically by the Windows. Okay, so but however in the file system mounting, okay, now we can see more useful, okay, in the Linux. Okay, this is example of file system mounting. Okay, whereby you have a directory structure. Okay, so you have mount your points. Okay, you mounting the mount points is whereby you mount to the other directories in order for you to access that particular groups of directory. Okay, you mount the device. Okay, you mount the directories to another project, to another groups of directories. Okay, so for example, like USR, artworks. Okay, a small point to the projects. Okay, so therefore the USR file name will access and can be able to access the project directories and also subdirectories of the subdirectories and also the file in the particular directory of the project, as long as the file system is being mounted. Another functions of the file system is allow for file sharing. So sharing of your files on a multiple user is desirable. Okay, on the distributed system, the file will be shared across a network. Okay, kita ada NF, for example, network file systems. Okay, alright, normally used in the distributed file system method. Okay, the system can either allow user to access the file of the other users by default, or it can be require users specifically granted to the file. Okay, so most of the system evolve to the concept of the file directory owners and file sharing ni banyak kita gunakan untuk do some protections and also security. Okay, we allow user or grant the users, okay, to share the files. Okay, either can be edit, okay, can be modified. Okay, and it depends on the access right and the simultaneous access. Okay, right, so share files. Okay, whether you allow for view, okay, for editing. Okay, so the access right have widely variety can be used by the various system, which is normally often in a hierarchy where one right implies, okay, the previous. Okay, so it can be based on none. Okay, the user may not know the existence of the file. It can be a knowledge where user only determine the existence of the file through the reading, updating, change the protections. Okay, where the user can change the access right granted to the user or change the permission. So dekat file sharing, bila kita click choose for file share, okay, we have to determine, okay, the shared permission setting. Okay, whether we have to allow for edit and view, okay, of the shared files. Okay, so the owner have a given commonly a persons who can create a file and have a full control of the file. Okay, so the owner of the file has a full access right, okay, for the file, and they grant access to the others. Okay, in the specific users, okay, we have individual users who are designated by the user ID, and the user group will set of users who are not individually defined. It's defined by the groups, and this will be system must monitor and keep the track of the membership of the user group, and all user have access to systems are known as a public file. Okay, so normally if you have a semantic access, when the access is granted to append or update the file more to the words users, the operating system or the file management must enforce this discipline. Okay, if you have a simultaneous access lah. Okay, for example, your database. Okay, so here is a simultaneous access by multiple users. So you have to provide some enforced disciplines. Okay, in terms of the access granted, so that particular file or to the particular directory. Okay, the brute force approach is allow user to lock the entire file when it's being updated. Contohnya kalau macam database, okay, database admin sedang tengah update, tengah update dia punya database, okay, dia akan lock. Okay, so that user will not access that particular file in the or record inside the database. Okay, so that the user will not have receive a garbage collection lah. Okay, So normally this file sharing is used in the network file systems, okay, or in the distributed file sharing method. Okay, dalam server lah. File sharing ni obviously banyak kita implement dalam server. Even in the personal desktop pun kita allow do file sharing. Okay, benda ni awak boleh nampak sendiri bila you right click. So this is the file protections. Okay, so the file owner should be able to control what can be done and by whom can access your file. Okay, the type of access can be a read, write, execute, append, and delete or list of the file. Okay, so this is a file access control method. Okay, in order to protect your file, we have a 3 method or 4 methods. Okay, in order to control the accessing file. So one of the method is access control metric. Okay, access control metric normally we provide a column identifiers to identify users and row as identity of the file and what kind of access granted or permissions that we grant to that each particular user and file. So access control list is used each user permit to access the file, read or write based on the category of the users. And the capability list will list the user and file based on the capability of each user has access. And log word control normally you provide your file or to be provide the passwords, okay, in your file as a part of the protection. Okay, this is the type of access. Whether you can read, whether you can write, execute, append, delete, and so on. In the access list and the group of the file, okay, and they have a mode access of read, write, and execute. Okay, basically read, write, execute will be represented by either in the text RWX or it can be by a value. In the Linux, basically you have you can either use values or text. So in the read access in Linux, okay, it can be represented by the 4, W will be represented by 2, and X will be represented by 1. So therefore, when you identify, okay, the owner of the access, okay, for example, as you want to read write access for the owner, you have a 7. 4 plus 2 plus 1, you got a 7. And the group access, okay, for the group access, if you only give a permission to read and write, so therefore you allow for only to read and write access, so it can be represented by the value of 4 plus 2 is 6. And for the publics, is allow for only for access. So execute. Okay, so you execute normally something like you can view only access. Okay, so you cannot modify. So access, okay, so which is execute can only one access. Okay, and then so therefore the values of the access of the permissions for the public access is only 1. So normally is you may use, okay, so the mode access, okay, normally used for the change mode permissions in the Linux, okay, whereby the change mode, okay, we can use 761 as a change permissions, okay, and for that particular game. So the 7s here will be represented by the owner, and the 6 will be represented by the group, and 1, okay, is represented by the public. So that's why in the change mode permissions in the unit is much easier, okay, compared to the Linux. compared to the Windows. Okay, because in the Windows you have to go to the wizard, okay, of the file sharing, of the change permissions in order to change the permissions of that particular group. Okay, so now we go to the file system architecture. Okay, they have two most commonly used of the file system architecture, okay, which is a Windows NT and also a Linux. Okay, so and also a Linux. So Windows NT, okay, use normally NTFS and also FAT, okay, file allocation table. And for the Linux, okay, normally we use the extended file system, either in extended 2 or extended 3. So file systems architecture is very important in order to identify the formatting of your operating system. So for example, here you can see that the most of MS Windows and 95 are using FAT. Okay, Windows 95, okay, using FAT 16 or FAT 32. And start with the Windows NT, okay, we can see that the file system architecture has changed, okay, to the NTFS. Even though it will still support FAT 16 and FAT 32, but mostly currently they are using NTFS. So for the, however, in the Linux and the Mac OS, okay, normally they are using the extension file system. Okay, so we go to the NTFS or New Technology File System. Actually, basically, this is a proprietary or file system that was designed by the Microsoft for the Windows NT version. It used 64-bit disk addresses, which is a support to the power of 64 bytes. And this NTFS allow access control list at the user level. So NTFS associate with the specific right unit the user and the groups in order to perform the backup file and also directories. So NTFS are more powerful than FAT32 with the improved access speed, performance, reliability, fault tolerance, complexity, security, as well as to support the long file name and the large volumes. Okay, the large file. Okay. Another type of the file system is in the Windows is the FAT, which is a file allocation table. So it actually a legacy file system, which is simple and robust. Normally, is this FAT we can find in the floppy disk, in the solid state memories, memory flash, and also the portable and also embedded devices. So this FAT is actually a file system architecture which is previously used in the Windows operating system. So FAT actually is a file allocation table which refers to your data tables that hold information about how and where is your files are being stored in any partitions in the single storage device, or it can be in the several partitions. Okay, so FAT, we have a two type of FAT here. We have a FAT 16, okay, and we have a FAT 32. So in FAT 16, okay, they use is 16-bit of addresses, and normally this FAT 16, the limited usage of these partitions not more than 2 gig. So therefore this FAT 66 is no longer used right now because most of us data storage more than 2 gigs. Okay, so this FAT 16, okay, mostly used in the floppy disk. Okay, this is the last time's format of file. Okay, format of your file system using a floppy disk. However, in a FAT32, they use 32-bit addresses, okay, which can support up to the 2 terabytes. Okay, however, in this FAT32, do not provide any securities and only used for the transportable media such as like a flash drive. so in the contiguous allocation table, okay, of this space, okay, we have a file, okay, and the start of the block and as also the length of the block. So this example of 32 block of a disk, okay, start with the block of 0 and until it will be block of 31. So for example, of we want to show how your file count is being allocated in this contiguous allocation space. Okay, the file count, okay, will start at the block 0 and the length is 2. So in here, okay, we can see that this block start block of the block 0 here, okay, and 1. Okay, so this particular block 0 and 1, okay, will be allocated to the count 5. Okay, another example of the file is the mail file. Okay, so mail file will start at the block 19, okay, and they have a length of 6. So the particular file, okay, will start at the block 19, go to the 20, okay, 23, okay, go to 20, 21, 22, 23, 24, and 24. Okay, so this particular file is used for the mail. Okay, so the way the files will be allocated start will be block 19, 20, 21, 22, 23, and 24. It should be contiguous, meaning that dia perlu secara berturutan lah. Okay, another example. Okay, we have block 4. Okay, we have block numbers 6. Okay, it's a F5. So this F5 have a 2 length. So this particular line I use different color. Okay, I use a red one. Okay, so this is red one. Okay, start at the block 6. Start at the block 6 and 6 and 7. Okay, so this one is belong to F. Okay, so this is how the contiguous action. It should be start with the block and it should be contiguous. That's why they give you a length of the block. Okay, another method of file allocation table is a link allocation. Link allocation. In this link allocation, okay, they contain each block have contain a pointer, and where this pointer will shows the first and the last of the block of the file. Okay, so in this directory, for example, we use a file zip. Okay, we start at the block 9 and at the end with the block 25. Okay, so let's say for example block 9 here. Okay, we start at the block 9 here. Okay, we start at the block 9. So okay, followed by the okay, let me draw back here. Okay, so they start at the block 9. Okay, they start at the block 9 here, and this particular block 9, okay, they have a pointer. All right, they have a pointer that point to the block 16. Okay, to the block 6. Okay, the block 9. Okay, the point at the block. Okay, at the block 16. Okay, 9. Okay, they have a pointer that block at block 16, and the block at the block 16. Okay, they have a pointer that shows to the block 1. Okay, okay, at the block 1. Okay, they have a pointer. They have a pointer. Uh, okay, okay, at the block point. okay, they have a pointer, okay, that shows okay, at the block 1, okay, so they shows, okay, the block of 10, and at the block 10, okay, finally they choose the block of 25. Okay, they start at the block here. Okay, the start block, okay, the start block at the block 19 here. Okay, they start at block 9 here. Okay, and followed by the block 16. Okay, block 16 here, and then they go to the block 1. Okay, and from the block 1 they have choose the next block is at the block 10. Okay, and then this block 10 will contain the final block, which is actually the block of 25. Okay, so therefore this is how the link allocations is being link allocations, okay, method is being used in order to allocate the file. Okay, another method is index allocation. Index allocation. So this index allocation method, okay, contain the file and also the index blocks. And so in this index block, okay, they shows that, okay, the index blocks will shows the starting of the index blocks, and then followed by the pointers. Okay, for example, okay, the index block here. Okay, they start at the index blocks. Okay, they point at the block 9. Okay, okay, this from the 19th block also. Okay, there will be point to the block 1. Okay, okay, we go to the block 1. Okay, from the block 19 also. Okay, right, they point at the block 10 here. Right. Okay, so here the block 9. Okay, nine. Sorry, from the block 9, from the block 19 also, there are point to the block 16. Okay, so bring this drawing pointer to the block 16. Okay, and then from the block 19 also they go to the block 1. Okay, and to the block 10. Okay, from the block 19 also they go to the block 25. Okay, and how about the negative one here? The negative one here shows the nil. Okay, alright. Nil means in the end. Okay, nil is nil, so not available lah. Okay, so So means that from the block 19 it goes to the block 19 it goes to block 9. Okay, and then they go to block 16. From the block 19 also they go to the 16, to the block 1, to the block 10. Okay, at the particular blocks. Okay, so the index blocks, okay, will contain the start of the references or the index for the allocations of that particular file G. Okay, so this is the differences between the NTFS versus FAT. Okay, so you have example here. NTFS, okay, will allow the extended file name and also the foreign characters, but however in the FAT16 it does not only have 8.3 character limitations. So in the NTFS, they provide the security with fast encryptions, while the FAT16 will provide only a space for the operating system to read the files. Okay, alright. That is for the Windows file system architecture. How about the Linux and the Mac? So in the Linux and the Macs, okay, normally they use the ext file extended file system. Okay, alright. In this extended file system will solve problem in the existing of the Minix. Before extended file system, Linux use a Minix file system uh, which can not support a file name, and the maximum file system only 64 megabyte only. So this ext is already, it has been improvised, okay, by replaced with the ext2 due to the performance and also the efficiency. So in the extended file systems, okay, of extended 2 file systems, okay, normally there will be in the groups. Okay, so will be in the efficiency. There will be have the blocks. Okay, by using a blocks. Okay, and this is the block is a block group 0, and we have until a block group n and minus 1. So in particular block groups here, okay, each of the particular block of groups, they have a super block, group cipher, block bitmap, and inode table, and also your data block. So normally the block 0 is normally for booting process. Okay, alright. As I mentioned before, the block 0 is used for the booting computer, and the disk partition will be divided into groups of block. Okay, and the limitation of the extended 2 is the performance is not intolerable. Latency and lost data during a power system or system will be crashed. That's why they use the extended 3 file. Currently, our Linux are using an extended 3 file system. Okay, so because in the extended 3 file systems, they provide the most robustness, okay, by providing a journaling system. Okay, journaling file system where all the changes, okay, are being tracked, and when they crash, the possibility of system corruption is less because they have a generalization. Okay, so they have a journalism. So these 3 type of journals, okay, they can have a journals, okay, we can contain the metadata and the content are saved in the journal, the ordered, and also the write back. So that's why in the extended file system, okay, architecture, in the Linux is most usable, okay, when you to do so for the recovery, okay, for the recovery, or use for uh, recovery for recovery of the data. Alright. So in the chapter 2.3, which is device driver, okay, the role of operating system in computer Input-output is to manage and control input-output operation and devices. So although the related topics appear in the other chapters, here we bring together the pieces of paint a complete picture of the input-output. So in this chapter where you will introduce how the device driver works in the operating system and how the operating system is manage the input device driver. So the control of device driver connected to the computer is a major concern of the operating system designer because the input-output devices vary so widely in their function and speeds. For example, your mouse, your hard disk, your tape, robot, which is a varied methods are needed to control them. So these methods from the input-output subsystem of the kernel, which separate the rest of the kernel from the complexity of the managing of input-output devices. Okay, in the device organization, so this is your application program, and this from the application programs, okay, the operating system will provide the instructions of input-output machines, and this output, the abstraction of input-output machine will have a device manager interface, which is a program to manage your device controller and as a supervisor mode software. So from this your device manager, so your application or your systems will be connected to your device controller through the system call and connected to your devices. Okay, so device driver is a part of the operating systems that can interact with the device controller, part of device hardware to manage the detail of input-output operation. So your device driver is actually a part of the operating system which compile the operating system and dynamically loaded into the operating system during execution. So each device driver handle each types of devices. So each of devices have their own device driver. For example, your USB, your mouse, your keyboard, your printer, your game console, and so on. So each of these devices have their own device driver, and this driver can separate it from the operating system because of the new function, or can be added to the driver without requiring any operating system to be modified, recompiled, and also redistributed. So device driver, for example here, so this is your application process. So application process, for example, kita tengok Microsoft Words. So from the Microsoft Words, when you request from the print, for example, by select the menu of print or Control P, okay, you are request to do some printing. So from this kind of interface will provide the printer properties of drivers, okay, and then from there you will select which type of printer that will be connected. Okay, so so once you choose the printer, okay, so for example Canon, okay, so your device driver of the Canons will be request for read, okay, from the to the device driver read command to the command, okay, to the device controller. So bila dia dah sampai kat device controller, okay, command, so dia akan bagi the device controller will provide a status, okay, alright, provide the status of your devices, whether your devices is being offline, will be ready, or is not, or is disabled, okay, and then this will be appear to your application process, okay, so your application properties lah, if you, for example, printer properties, so you can see that the printer properties of the status of their devices will be appeared. So then when you submit the printing of your data or the documents will be sent to your data to the device controller. So it depends on the devices, whether the input devices, whether it's output devices. Alright, so this is some functions of your device driver. Okay, so what are the driver responsibility? So device driver are responsible, okay, in order to initialize the devices. For example, your monitor, your keyboard, or your mouse will be initialized, okay, during the booting itself. Okay, and then interpreting commands. Okay, selain daripada itu, dia juga interpret the command from the operating system. Operating system. So dia juga akan schedule the multiple outstanding request of input output, sama ada you nak read, write, okay, examples, okay, and so on. Okay. Okay, so the manage data transfer from to the devices or to or from the memory to the CPU. Okay, so they accept and process interrupts, check the device status and control the device to allow the modification of its attributes. Okay, so this is the types of device driver. Okay, each of type device driver have their own device driver interface. Okay, for example, for the character device. So the character device interface is normally used as sequential access method. Okay, and access is through the stream of bytes and there's no buffering. For example, your keyboard, your printers, your sound card, which is required or related to any of the text or text symbols and so on. Okay, so for the block device interface, okay, block device interfaces normally they have use a random access method. Okay, and normally it can be a buffering, okay, depending on the size of your block devices interface and the speed of your block device interface. And example, okay, normally the block devices is normally can do some storage and have an availability in order and capability to store your data in terms of like a storage, any kind of storage, like for example your flash memory, okay, your hard disk, your CD-ROM, your DVD. So all these things can be categorized into a block device driver. Okay, and we have a network interface. This normally network interface is any devices that related to you to connect with the network internet connection. For example, your modem, your network interface card, your wireless adapter, your wireless Ethernet adapter. Okay, so this is all these things, okay, will requires our network interface, because this kind of device driver are able to exchange data with the other host, able to send and receive data packets, okay, through the network, and it will be designed around the transmissions and the receipt of the packets. Okay, so the device controller. Okay, so in this the device controller basically were not learned yet, okay, during our subject CSC159, because this will be more focused on this operating system, because most of them is being managed by the operating system. Okay, so now how can processor give a command and data to the controller to accomplish the input-output transfer? The short answer is that the controller has one or more registers, such as a data register, command register, okay, status register, and also data register. So the processor will communicate with the controller by reading and writing the bit patterns in this register. One way in which the communication can occur is through the use of special way in which this communication can occur is through the use of the special input-output instruction that specify the transfer of byte or words to the port input-output port address. So from the device controller, they will communicate through the port, okay, or through the system bus, okay, or you can map directly to the input output, and or you can use a memory map input output in order to send to send your data, to receive your data, or to send the instructions. Okay, the input-output instruction trigger the bus line, okay, and select to the proper devices and move the bits into or out of the device register. So alternatively, device controller can also support the memory map input-output. So dalam kes ini, device controller register map into the address space of the processor. So CPU akan execute input-output request using a standard data transfer instruction to read and write the device control register, and they are map the location, okay, of in the physical memory. Okay. Alright, so for example, the device controller might contain a command register to which the device driver can write the device command to the start and operation on the devices. So device controller is also likely to incorporate a status register the device that the device driver can read to determine if the operation input-output operation completely successful, or it moves the recent device operation resulted in an error. The status register will report the nature of the error. Okay, for example, like you are printing, so during the printing operation, during the printing operation okay during the printing operation during the printing operation, okay, you will have paper jam, okay, or paper stuck okay during loading the paper. So the error of the paper, the error will be notified or will give to the status register and report, okay, to your application system. So you will see the hand error or the paper jam. So you have to do some action in order to mitigate ataupun untuk pastikanlah, okay, paper tu dah tak jam ataupun paper tu stuck, so they will will continue or resume you punya printing. So device controller also typically contain one or more data register where the data is to be written to the device and stored before starting the write operation, or where the result of the read operation is retrieved when the device finish the read operation. Okay, so device controller. Okay, so what kind of interface to the input-output controller? So it can be in the form of control signals, it can be a status or data signal. So the data, we can have a set bit of to be sent or received input a controller. For control, they have a function such as the open function, request function, read function, write functions, okay, in order to receive or send data to or from the input controller, okay, or accept data from the input output controller. It depends, bergantung kepada types of devices tersebut lah, sama ada di input device ataupun di output device. So the status will be indicate the status of the devices such as ready or not ready in order to show whether the devices is ready to transfer. It's mostly obvious bila you nak printing. You akan nampak bila you printing, bila you nak print. Okay, so when you select the printer, they give you status of your devices: not connected, disabled, not ready, offline. So kalau nampak offline, baru on. So bila you on, you nampak. Okay, you akan nampak status daripada offline to become ready. Okay, so then when you dah select the settings of the of your printing documents, so you akan send the documents and do the another jobs. Okay. Alright, so example of data transfer from devices to CPU. So CPUs, okay, data transfer from device to CPU. So CPU will interrogate, okay, the input-output controller to check the status of input-output devices. So then the input-output device controller will return the device status, and if the device is ready, then the CPU requests a transfer of data and send the command to the input-output module. Then input-output controller will obtain the data, and the data will transfer from the input-output controller to the CPU. Okay, so the device manager is used to manage the hardware devices installed in a computer, such as a hard disk, keyboard, sound card, USB, and devices. So in the act of the master list of hardware that operating system understand, all the hardware on your computer can be configured from this centralized utility. So how is your devices manager can be accessed? Device manager can be accessed in the several different ways. For example, you can do through your control command panel, so through your setting, okay, command prompt or computer management, which is as being shown during your lab hands-on. How it can be used? Each device listing the device manager contain, okay, the detailed driver, system resources, and other configuration information and setting. Changing this setting for a piece of hardware will change the way of operating system works with the hardware. Okay, so when you have a device manager, so you have a kind of software you can use through the device manager. On the device manager, you have a list of devices and you can click each of your devices. You right click, you can have update drivers, reinstall drivers, okay, view the device status, rollback, enable device or disable device, and find the driver's version number. Okay, so the device manager can be a synchronous input-output or non-blocking input-output. It's a form of input-output processing that permits other processing to continue before the transmission has been finished. Or it can be some of the devices are using a plug and play. Plug and play is one of the specifications that facilitates the discovery of a hardware component in the system without the need for the physical device's configuration or user intervention in resolving the resources conflict. For example, is USB. When you connected your USB, they are plug and play without need any device configuration, because they will be installed for the first time. They will be installed the device driver, and then after later on, when you want to use the pen drive, you just plug and play, then will be you can use, okay, the USB as usual without any device configuration. Okay, so now we are going to device driver interface. We continue our lecture. So device driver interface, okay, each operating system has different architecture for its device management system. For the Linux, okay, they have the way of architecture in order to manage your devices. Windows also different, and also a Mac also different. So the design differ from the design of the device driver interface depending on the operating system or with the others. Okay, there's no universal organization use the same of the device driver interface. Okay, for example, like a Linux. Okay, so the in the Linux, normally the nature of when you want to enable your devices, okay, before you into devices, you have to use a command line. Well, however, in the Windows, you can manage your device driver interface through the graphic user interface. Okay, each operating system have two major part interface to the device manager, either through the device API, device driver API, or in the device interface between the driver and also the operating system kernel, or they call a device driver kernel interface. Okay, so what is usually API? API is Application Programming Interface, and it is an application method. Actually, it's a code, which is an application method, which can be used to access a certain functions of your devices through the applications interface. So the system API provide the interface between the applications and also the system resources through the system call. So what are the responsible device driver API responsibility? So they provide a set of functions that which programmer can call to manage the devices. So, for example, they have open-close functions in order to allow or initiate the or terminate of the device use. So, open functions basically is locate the device and initialize the tables and the devices that will be used in your computer system or into your So how about the close? Is a release dynamics, okay, tables, entries, and release the devices in order to close your use of your devices. Okay, some of them are confusing. What is the difference between the device driver and also the device driver API? So drivers enable the hardware to be utilized fully by the software. For instance, without a driver, a GPU wouldn't have much in the way of power management features and downclock while idle. That would be awful for the battery life of the laptops. Okay, how about the API? So, okay, so Microsoft has created the Directs API as part of the Windows, which provide the operating system function for drawing graphics on screen. So it creates a standard or uniform interface that any graphic card can use to plug into the operating system. So the graphic cards, okay, come with a driver which control that specific graphic hardware to do the work and call the operating system's API to integrate the card into the operating system. So API lets the operating system work with any compatible graphic card without knowing much about each card's specific hardware. So each card's driver will translate between that card's hardware and the standard of operating system API. So API can be a template for the programmer to use in the software in order to get access to the desired features or outcome. So the driver will interpret the API that used by the software in order to give them the desired features or outcome from the hardware. So that's the difference between the device driver and also device driver API. So this is some another functions of device driver. We have a read-write functions. It allows to the programmer to read or write from or to the devices. Okay, and IOCTF functions allow programmer to implement device specific functions. Okay, so this example of the APIs, okay, will be created by the programmers in order to have interface between your applications towards the other system. So, for example, they have an advanced cinematic operating system we call ATOMS, and these operating systems in the cloud services, okay, whereby this will be demand, okay, in order for you to use in the web base, okay, in the network, in the mobile phone, and also in the car, for example. So they have to create the API from these particular applications to other devices. Okay, for example, inside the car, inside the mobile phones, okay, inside the web base, okay, or inside the wireless technology, okay, or their storage. Okay, so the device driver kernel interface. So the device driver must be executed in the privileged instruction when it starts devices. So device driver API will communicate through your applications. So once your applications is being initiated, which are devices that being used and which device driver is being initiated. So then where they are going to the privileged instruction, or we call in the privileged mode, in order to start your devices to be operated. This means that the device driver must be executed as part of the operating system rather than the part of a user program. So the device specific code in the kernel will interact directly with the device hardware. It supports the standard and the internal interface, okay, between the user and also applications, okay, user applications, and also to the devices. Okay, they use the same kernel input output systems which can interact, okay, easily with the different device driver. So when your device driver want to connect to your devices, this must be connected through at the operating system level, which is through your kernel. Why in the kernel? Because your kernel knows where is your device driver is being allocated. So there will be special devices. We have a specific configuration. So this device kernel interface requires special device configuration supported with the IPOs through the system call. Okay, so this is the device drivers. Okay, kernel interface. Okay, so this is your kernels. Okay, so this is your kernel. Okay, of your operating system, depending on what kind of kernel that you use. Okay, and then the kernel input output systems. Okay, the purpose of device driver layer is to hide the differences among device controller. Okay, your device controller, and okay, and the input output system of the kernel. Nak differentiate between the device controller and also device of input output subsystem of the kernel. So much as the input output system call akan encapsulate the behavior of the devices in a few generic classes that hide the hardware indifferences from the application. So making the input output subsystems independent from the hardware will simplify the job operating system developer. So that's why the input output system ni dia ada independent compared to buat satu-satu for each type of devices. So mudahkan, simplify lah in order dia nak manage the hardware. Sebab hardware kalau akan ada banyak. Okay, yang connect dengan kita punya computer system. See also benefit of the hardware manufacturer. They can design the new devices to be compatible with the existing host controller interface. Okay, and for example, we have a SATA, okay, hard disk, okay, or they write device driver to interface the new hardware to popular operating system. So thus, we can attach the new peripherals to a computer. Okay, ini memberi kelebihan kepada hardware manufacturers lah. Bila dia ada new devices, they implement or invented the new devices, dia akan post je dekat dalam operating system, update je dia dalam operating system, update dalam operating system in order for that new devices of the device driver can be read and write to the particular of operating system. Contohnya ramai pakai Windows, so dia akan invent the hardware of the new devices dekat dalam device driver di dalam Windows platform. Or it's a Mac. Okay, currently orang ramai suka pakai Mac. So the device driver also can be compatible and support in the Mac operating system. So therefore, kita akan attach new peripheral devices to computer without waiting for operating system vendor to develop the support code lah. So macam contoh, macam kita ada game konsol ataupun kita ada stylus pen. So benda tu tak perlu nak operating system operating system developer in order to create the device driver for the stylus pen. So because the stylus pen will come with a plug and play. So bila tu dia akan ada device driver that running all together and they will be attached sahaja dekat dalam computer and can be operate as usual. Okay, so kernel is the main core of your operating system. Okay, so the primary purpose of the kernel is to manage your system resources and provide the interface so the other program can access these resources. Okay, so this is hard system hardware to present an abstract programming interface in the form of system call and also library function. So they will be hiding. So kita akan nampak detail lagi nanti detail operations in the kernel part dalam operating system in the system perspective view. So they provide abstraction and manage all the following concepts such as processors, resources, virtual memory, file system, IPC and so on. So the device driver kernel interface will provide the driver to manage the interaction with the specific devices. Normally this device driver kernel interface will be written mostly in C and with a little assembly language for the low level processing. So depending on the kernel types, for example like a Solaris, they can design dia punya device driver kernel interface using a modular kernel. So it can load the device driver as they are needed and discover any new devices automatically, result in the search and the load of the corresponding module. So ini contoh dalam Linux. So kalau dalam Linux dia kena compile time about the devices in the system. Dia kena mount dulu. Biasanya Linux, tak kisah Linux, any Linux distribution system. So once you want to use the devices, you have to mount the device drivers first in order for you to use the devices. So this is the applications, okay, in your user space. And so this is the system call interface, okay, melalui device driver API. So dia akan kena connect dengan kernel subsystem, or we call input output kernel driver interface of the kernel, and then connect to your device driver, and then barulah dia pergi kepada this controller, and this controller akan connect through your devices. Okay, so that's all for the topic 2.3, and that is all for the chapter 2 for the operating system of user view. Thank you.